lesson is about the third degree function. And this is the standard form of the third degree function. How do you know whether it's a third degree function? It has a cubed function as the highest exponent. Now, if I want you to draw this function, this is a new function. You already know the straight line, the hyperbole, the parabola, etc., etc. This is a new one, the third degree function. And you need to know how to draw it. There are 5 steps. The first step is to determine the form. For the form, you look at the value of A. If A is positive, then the graph looks like this. You start at the back. It's a smiley face, and then it goes down. So it's rise and smile for positive. If the form is negative, so if A is negative, then it is down and frown. Then it looks like that. The second thing that you need to know is to get the y-intercept. How do you always get the y-intercept?
X0.
You make x0. The third step is you get your x-intercepts. How do we always get the x-intercepts? Make y0. But now we have 3 x-intercepts. So first we need to find a factor. Then you have to do synthetic division. And then you have to factorize the last factor. And then you get your 3 intercepts. Number 4 is your turning points. If we look at our graph, the turning point will be there and there. That's where they change direction. So we always have 2 turning points. But there's an exception, and I will tell you when that will be. If you look at the turning point, here my gradient is positive. What will the gradient be here? Negative. And here?
Positive.
What will the gradient be on top of the turning point?
0.
Very good. How do you show gradient as a formula? F accent x. Can you remember from differentiation? That stands for gradient. And on the turning point, the gradient is 0. Then we also have a point of inflection. That is this point here, halfway through the 2 points of turning. Halfway is the point of inflection. Are you awake? Are you? No. So, the point of inflection is the point when the concavity turns. up until here, it's concave down. It's a bucket downwards. From there, it's concave up. So it's a little bowl upwards. So the point of inflection shows you where your concavity turns. And the point of inflection is the second derivative set to 0. These are the 4 steps to draw the cubic function. Now I just want to show you here on the sketch. Those 2 points are my turning points. Halfway between the turning points, we get the point of inflection. We also have our 3 x-intercepts and 1 y-intercept. If it's a positive graph, this is called the local maximum. And this is called the local minimum because it has a maximum value there, but it's only local because we can carry on here with other maximums. And this is a local minimum, but it's only there because we can carry on here to a lower minimum. Right. The other word for a turning point is a stationary point. So if I ask you, determine the stationary points, I actually ask you, determine the turning points. Now let's look at our first example. Fx equals to x cubed plus 4x squared plus x minus 6. The question is, draw the sketch. So we need to first get the form, then the y-intercept, then the x-intercept, turning points and point of inflection. But we also need some little homework. We need to get the first derivative and the second derivative. So do that first. Let's do that now. So the first derivative is 3 times 1 is 3x squared plus 4 times 2 is 8x plus 1 times 1 is 1, x to the power of 0 is 1. Now we get the second derivative. Where do I get that from? From the first one. So I have to differentiate this one again. 3 times 2 is 6x plus 8. Now you start with your steps. Number 1 is the form. What will the form of this one be? Rise and smile. It's a positive one. Then we get the y-intercept. So we make x 0. Y equals 0 to the power of 3 plus 4, 0 squared plus 0 minus 6, and that will give you negative 6. Now a good thing is always to write your coordinates after you have worked out something, because you use your coordinates to plot and then draw your graph. The first coordinate will be 0, negative 6. Number 3, we get our x-intercepts. First, we must find a factor. So I've already done that for you, and it is 1. You must show that it is a factor, so you have to show your substitution. 1 to the power of 3 plus 4, 1 squared plus 1 minus 6.
So if we really find a factor, you say 1 to 5 for your minimum investment. And this is 0, 0, 0 in everything. In the item 1,
You still have to go through the motions. Okay, therefore, x minus 1 is a factor. Now we need to do synthetic division to get the other factors. I'm going to divide with 1, and my coefficients are 1, 4, 1, minus 6. Below the first one, there's a 0, and now I add. 1 plus 0 is 1, multiply, 1 times 1 is 1. Add, 4 plus 1 is 5, multiply, 5 times 1 is 5. Add, 1 plus 5 is 6, multiply, 6 times 1 is 6. Add, dot. Now you write your variable, it's x, 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 and you put in your exponents, 0, 1, 2. Therefore, x to the power of 3 plus 4x squared plus x minus 6 was 0. And we got our first factor, x minus 1. Our second factor is here, x squared plus 5x plus 6 equals 0. But we need to factorize the second bracket as well. And you get x plus 2, x plus 3. So my 3x values, I'm just going to write them here, will be x equals 1, or x equals negative 2, or x equals negative 3. But I have to write the coordinates. So it will be 1, 0, minus 2, 0, minus 3, 0. We must get the turning points. The turning point is where the first derivative equals 0. So my first derivative was 3x squared plus 8x plus 1 equals 0. There is no way that you can factorize that one. So what do? You use your formula. X equals minus b squared minus 4ac over 2a. And then you get x equals negative 0,13 or x equals negative 2,54. But I want a coordinate. So I need to get the y value. How do I get the y value? Substitute the x into what? I've got 3 equations. The first one, always substitute into the original one. So I substitute it into f, negative 0,13, and then you get negative 6,06. I substitute minus 2,54 into f, and then I get 0,88. So my two coordinates will be negative 0,13, negative 6,06, or negative 2,54, 0,88. Now I need to get the point of inflection. You take the second derivative and set that equal to 0. The second one was 6x plus 8 equals 0. So 6x equals negative 8, and x will be negative 8 over 6, which will give you minus 1,33. That's only the x value. I want a coordinate. So I need to substitute this x value into what? Original f. Minus 1,33 equals negative 2,61. So my coordinate will be negative 1,33 and negative 2,61. There I have all my coordinates. And now you plot them. I'm just going to show you this one. You have that on your notes. You plot your three x values. You plot your y-intercept. You plot your two turning points and the point of inflection. And when you draw your graph, it's one continuous movement. You can't do it like this. That's wrong. It must be one flow. Okay. Oh, many. Many. Okay, kom ons kyk. You'll get a mark for your y-intercept. You'll get 3 marks for your x-intercepts, 2 marks for your turning points, and 1 mark for the point of inflection, and maybe 3 marks for your sketch. Yeah, lekker baie. Okay, now I want to show you something else. This is not in your notes. Nee.
Oh ja, das ist das Budget.
You can get 3 variations on your x-intercepts. You can get 3 intercepts that are all different. Then your graph has 3 x values. But what happens if you only get 2 intercepts that differ and one of them is the same as the other one? So you get 2 times, for instance, x is negative 1, x is negative 1, and x is 2. That means that these two show you the turning point on the x-axis. Okay, so the two that are the same tells you it's a turning point on the x-axis. if you have only one x-intercept and you work out your turning point and your point of inflection, and they are the same coordinate, that means that the graph sort of is not two turning points, but we shifted it a little bit to look like a propeller. So now the graph looks like this. That's when you get your turning point the same coordinate as the point of inflection. Then the graph, it looks like a propeller. Alright, time is running out, so I'm going to just show you example 2. Example 2 only has 2 terms. One is a cubic x and one is a constant. So this should tell you, give you warning lights. This is not a normal cubic function. The graph will look some way different. Okay. The form is negative, so it's a down and frown. The x-intercept, when you make y 0, you will get negative 1 and 0. So there's only one x-intercept. The y-intercept is where you make x 0, you'll get a negative 1. The turning point is the first derivative set to 0, and you get 0 minus 1. The next one, the point of inflection, second derivative set to 0, and you get 0 minus 1. So, my turning point and my point of inflection is the same coordinate. But it's also the same coordinate for the y-intercept. So, this is definitely a propeller, and it would cut the y-axis at negative 1. A propeller, and it will cut the y-axis at negative 1.
So if there's only 2 terms and a constant, is it a chain that is always going to be a propeller?
It should be a propeller, yes. Okay, that never call it a propeller. It's a propeller. Alright, that concludes our lesson for today. Your homework for tomorrow is exercise 7, page 29, number 1 to 4. Don't leave it for after dinner. Start early.